This is HRW99P048. Okay, so we've got particle A and particle B are held together with a compressed spring between them. When they are released, the spring pushes them apart and they fly off in opposite directions, free of the spring. The mass of A is 5 times the mass of B. The energy stored in the spring was 131. Assume that the spring has negligible mass and that all the stored energy was transferred into the particles. Once that transfer is complete, what are the kinetic energies of each particle? Okie dokie. So, I've drawn a picture here. A and B were basically one big particle to start with, but then the spring sprung apart, and now we have A and B flying off in different directions with velocity A and velocity B. I do know that whatever energy they have now, that's the total kinetic energy, and it had to come from the spring. So all of that energy came from the spring, and it was 131 joules. I want to know kinetic energy of A and kinetic energy of B. So let's look at this as, this is a recoil situation first. So when this thing sprung apart, it conserved all of its momentum. So the momentum it used to have was right here. It was at rest, so the momentum it used to have was 0. Then, explosion happened. This is just another way of saying it. They exploded. You know, the spring pushed them apart. This is an explosion. Anyway, what I've got is I've got A going, I'm going to call that the positive direction here. So what I have is the mass of A times the velocity of A. And then minus, I've got the momentum of B, so I've got the mass of B times the velocity of B. Alrighty, so that's what I have. Okay, so really what we're saying is that the two momentums have to be equal in magnitude. That's what we're really saying. Like that. Alrighty. Well, I know that the kinetic energy of A is 1/2 mass of A, velocity of A squared, and the kinetic energy of B is 1/2 the mass of B, velocity of B squared. Okay, so what I have, I also have some information like the mass of A is 5 times the mass of B. And now I've also got this information. If I put that in here, let's see. Okay, so for instance, the mass of A is 5 times the mass of B. So I can replace right here the mass of A. I can replace that with 5 times the mass of B. Okay, and then everything else is the same. Okay, notice I now have velocity, or I'm sorry, not velocity. I now have mass of B on both sides, so that's going to cancel. So what I have is the 5 times the velocity of A equals the velocity of B. All right. So with this, let me just circle these things. With this and this, what I'm going to do is I'm going to get both of these in terms of either A or B, because that'll make it'll make me able to put them together, and then I'll whittle my way down to like 2 equations and 2 unknowns. Okay, now it's kind of up to us. Which one do we want to do? You know what? I've got space to solve this one for A, so I'm going to go ahead and do that. To get both of these in terms of either A or B, I've got to solve one of these the other way. So I'm going to do this one. So I'm going to have the velocity of A is 1/5 the velocity of B. So divide both sides by 0.5. Yeah, anyways. Okay. Now I'm going to replace whatever I can with these. So for instance, let's see, what do I want to do? Yeah. Okay. When I put these two together, I know they're going to equal 131. So I'm going to go ahead and solve basically this, because I've got, hang on, red here. I had that Ka plus Kb, oops, sorry, equals 131. So I'm going to solve that for one of them. Let's just solve it for Ka. I don't know why. Equals 131 minus Kb. Okay. Let's see. So if I put that up here, what I get is 131 minus KB equals, let's see, KB, let's see, oh, equals 1/2 MA VA squared. Okie dokie. Now I'm going to take these A's things so I can replace all the A stuff with B stuff, and then I'll have an equation with just B stuff in it. Just B stuff in it. So this stuff over here, just copy it. 1/2. Well, MA, that's 5 MB. So 5 MB. And VA is 1/5 VB. So when I square that, I get 1/25 VB squared. Okie dokie. Okay. Combine it. Ow. Sorry, I just shifted it. My leg is asleep. Isn't that lovely? Okay. Okay. This is going to get really confusing. I'm sorry. So really, I've got what I have here is I've got this equation and this equation. I want to put them together now. I know, it's this crazy stuff. So, let's see, what's the easiest way to do that? I guess it doesn't really matter. I'll start for MB. Why not? So MB would be multiply both sides by 2, divide by VB squared equals MB. Okay, gonna put that in right there. And so this becomes 131 minus KB equals 1/2. Let's see. I'm going to put this 5 and this 25, 1/25 together. So that would be 1/5. And then replacing MB with 2 KB over VB squared. Doot. And then, okay, I combined that 25, so it's gone. So what I'm left with is a VB squared. Oh, that's convenient. Look at that. Okay, these go away. So now I have 131 minus KB equals, well, let's see, all of this is gone, this gone. All I have is KB over 5. Alright, so then KB, oh, let's see, let's move this to the other side. 131 equals, let's see, KB over 5, but 5 plus KB, oi, which is the same thing as KB times 1/5 plus 1, alright, which is, what is that? That's 6/5. 6/5 KB. Come on. Yeah, come on, you can do it. Alright, so multiply both sides by 5, 6 to get rid of these. And what I have is that KB, come on, is 5, 6 times 131, which according to my calculator, let's see, 130, come on. Come on, clear. 131 times 5 over 6. That's 109. 109.2 joules. Ooh, that's a funky looking J. Let's go check that. KB 109. Oh, they just have 109, not 109.2, but that's okay. So then to get particle A, you go back to, I know that KB plus KA equals 131, so 131 equals 109 plus something. You find the something, and that's KA. KA ends up being 21.8. Okay, so I know basically this problem is just a bunch of algebra. Look at all this algebra. Oh, love you the algebra.